Got another exam question walkthrough for A-level chemistry. So this is paper 3 questions number 42. If you want to check out the other videos in the playlist, I'll put the link to that at the top of the screen now. So the question covers quite a few topics: bond enthalpy, enthalpy changes, testing for chlorides, organic molecular formula, and chiral centres. Hope you find the video helpful, and if you haven't already subscribed to the channel, I'd love you to do so. But as always, the link to the questions in the description of the video if you want to try it first. So part A, we've got this equilibrium with methane, steam, hydrogen, carbon monoxide. We've got the enthalpy change, and we've got some of the average bond enthalpies in that table. And the first question, why do all average bond enthalpies have a positive value? So we've got covalent bonds in these molecules. I know this is not one of the ones in the table, it's just one I had at hand. So bond enthalpy is a measure of the energy required to break a mole of a particular covalent bond. So to break a covalent bond, you have to put energy in. It's an endothermic process. Next part, we've got to determine the CH bond enthalpy. So that's obviously in the methane in kilojoules per mole, using the information above. So when I teach this, I refer to this as an in minus out calculation. So just quickly explain that. The enthalpy change for a reaction, when you're using bond enthalpies, can be calculated by calculating the sum of the energy that you've got to put in. So you've got to put energy in to break all the bonds in the reactants, minus the sum of the energy you get back out when you make the bonds in the products. So in minus out. So there's all the numbers in there. The 4x refers to those 4 moles of CH bonds in methane. So ultimately we're going to solve for x to get the answer. So I've just tidied up the brackets a little bit. So 195 equals 4x plus 928 minus 2385. That's the sum of that bracket there. And now I'm just going to isolate that 4x. So that 4x comes out as being equal to 1652. We want to know what x is, so we're going to divide that by 4. So that means that that CH bond enthalpy is plus 413 kilojoules per mole. And the next part of the question, so we've got some information about hydrogen being used as a household fuel. We've got the enthalpy change of formation for liquid H2O. And we're going to have to use that to determine the energy released when that volume of hydrogen is used as a fuel. And we've got a requirement for our final answer, 3 significant figures and in standard form. So the first thing we need to appreciate is the equation that accompanies this statement here. Delta HF for H2O liquid is minus 285.8. So there's the equation for the enthalpy change of formation of H2O liquid. Remember, it's the enthalpy change when 1 mole of a compound is formed from its constituent elements. Now, the thing we've got to appreciate here is that this equation is also the enthalpy change of combustion of hydrogen. So when 1 mole of hydrogen is completely combusted, the enthalpy change is that. So in other words, 285.8 kilojoules of energy are released. So if we know what 1 mole will release, we just need to work out how many moles of hydrogen is in 60 cubic meters, and then we can just scale it up. So the moles of hydrogen is the volume, meters cubed to decimeters cubed, we multiply by 1,000. So 60,000 decimeters cubed divided by 24 molar gas volume. So we've got that many moles of hydrogen. So that times that will tell us how much energy will be released. So the calculated value is that, but they wanted in 3 significant figures and standard form. So it's going to be 7.15 times 10 to the 5 times 10 to the 5. Moving on to part B. So the first thing we'll do is write the ionic equation with state symbols. Don't forget those for the reaction in step 2. So what's happened in step 2? Colourless solution. There's chloride ions, remember, in this. Reacts exactly with this amount of silver nitrate solution to form a white precipitate. So the silver ions, the aqueous silver ions from the silver nitrate solution have reacted with the aqueous chloride ions from compound A solution and that's made that white precipitate of silver chloride. So that would have a solid state symbol. So moving on to the second part, we've got to determine the formula of compound A. So remember, compound A is this period 3 chloride. So it's going to have a metal ion in there and obviously the chloride ion. So I've represented step 1. So the students dissolved compound A, and it's obviously just dissolved in water. So you're going to have the aqueous metal ion. So that's going to have a certain charge. And you're going to have N. So whatever the charge is, you're going to have that number of chloride ions in solution as well. Okay. So and then step 2, they've done that addition of silver nitrate solution to get the precipitate. Right, so the first thing we're going to do is we're going to calculate how many moles of silver nitrate have been used in step 2. So that's just concentration times volume. Remember, the volume has to be in decimeters cubed. So 60 cm cubed is 0.06 decimeters cubed. So they've used 1.5 times 10 to the minus 3 moles of silver nitrate solution, which means that they've used that many moles of silver ions. And look at the ratio. There must have been that many moles of chloride ions in the solution. Okay, so the thing to appreciate is that these moles here, where did they come from? They came from this step. So these must also be 1.5 times 10 to the minus 3. Next thing we've got to appreciate is the moles of A that we used was 5 times 10 to the minus 4. So 5 times 10 to the minus 4 moles of A generated, when it dissolved, 1.5 times 10 to the minus 3 moles of chloride ions. So all we need to do is work out the ratio between that and that. So the 1.5 times 10 to the minus 3 is 3 times bigger than the 5 times 10 to the minus 4. So the ratio of A to Cl minus is 1 to 3. So that means that the metal must be a 3 plus ion. So it's aluminium. So identity of A is AlCl3. Moving on to part C. So the molecular formula of compound B is that there, C13H19N3O7. So the little black dots that I've drawn on there, they show where the hydrogens are, and you can see obviously you've got 2 hydrogens here, and you've got 3 there. How many chiral carbon atoms are there in one molecule of compound B? So we're looking for carbon atoms that have got 4 different atoms or groups attached. So I've highlighted the 4 chiral carbon atoms in the molecule, so there's 4 there. And finally, the difference between the relative molecular masses of C and D. So there's just a reminder of B's molecular formula. So compound C, the nitrogens are replaced with phosphorus, so there's the MR for that one, and D, the oxygens replaced by sulfur, so there's the MR for that one. So the difference between those two numbers is 61.7.